Welcome back to the GCSE Maths Pro YouTube channel. Today we'll be going through my own predicted paper 2. This is based on Edexcel past papers from paper 2 and paper 3 for higher tier. As it's mentioned in the disclaimer, please do not use this predicted paper as your source for the only topics or questions that will come up in the exam. Try to revise as much of the syllabus as you can, as we can never really predict what will come up and what will not. This should just be an extra paper for you to practice alongside the rest of your revision. So question 1, we have a Venn diagrams question. So the universal set is for odd numbers between 10 and 30. When it doesn't list what's in the universal set, I just tend to write them down myself so that then I can tick them off. So I've listed them here. The universal set represents the whole Venn diagram. So all of these numbers will appear somewhere in the Venn diagram. We've then got that A is prime numbers and B is 15, 17, 21, 27 and 29. Complete the Venn diagram for this information. So normally I just go through in order and say, right, 11, it's a prime number, so that will go in A. And then cross it off. 13, also a prime number in A. Now 15 is in B, but it's not a prime number, so just B. 17 is both a prime number and in B. 19 is just a prime number. 21 is not a prime number, but it's in B. 23 is a prime number. 25 is not a prime number and it's also not in B, so that one would have to go on the outside. 27 is just in B, and finally 29 is prime and in B. So now I've got all of the odd numbers between 10 and 30. A number is chosen at random from the universal set. Find the probability that the number is a member of A union B and then the apostrophe. So, first of all, the union bit, the U shape means or, A or, and then the apostrophe means not. So that's A or not B. For A, let's highlight A, that would obviously be the whole circle of A. And then not B would be everything outside of the B circle. So you can see what we've got. Now, because we are talking about A or not B, it's anything that's highlighted. Doesn't matter if it overlaps or not, it's just anything that's highlighted. So how many numbers is that? 1, 2, 3, 4, 5, 6, 7. So our numerator for our probability would be 7. The denominator is obviously then out of the whole universal set, which is 10. So 7/10, or obviously if you wrote it as 0.7, that's fine as well. Question 2. Part A, make Q the subject of the formula. P is equal to the square root of 2Q minus 5. So first of all, I'm going to move the 5 because that's just on its own, isn't it? Add 5. Then I'm going to square this whole side. I'm not going to expand it, I'm just literally going to write it in brackets squared. And then the last thing is obviously to divide by 2. So P plus 5 squared over 2 is Q. And now you've got Q as your subject. Part B, we've got x to the power of 5 times x to the minus 4 over x to the power of n is equal to x to the power of 8. Find the value of n. So I'm going to simplify the left-hand side by using my index laws. The first one in the numerator is to add. 5 plus minus 4 is obviously 1. Still over x to the power of n is x to the power of 8. Then I'm going to divide, which means subtracting the powers. So I've got x to the power of 1 minus n is the same thing, or is equal to x to the power of 8. Now I can just compare the powers. So technically, 1 minus n gives me 8. And you can just rearrange this. That would give you n is minus 7, negative 7. For part C, we've got factorise 8x cubed minus 2x. So this initially does look like a single bracket factorisation, so let's do that. We can pull out, in terms of the highest common factor for numbers, 2 is the biggest, isn't it? We can also pull out for letters an x as well. And then inside we would be left with 4x squared minus 1. Obviously the 2x is the same as what's on the outside, but it's not 0, it's still there, minus 1. Now the only other thing to then consider is that this bracket here is difference of 2 squares. 4x squared minus 1 is difference of 2 squares. So we can factorise it again, leave your 2x on the outside, and then into double brackets, we can do just the square root of both. That'd be 2x, 1, 2x, and 1. And then 1 is always a plus, 1's always a minus. So actually that one did factorise into double brackets as well as initially single brackets. So actually always just double check, do I have difference to 2 squares somewhere, because it will definitely come up within some kind of question throughout the 3 papers. Question 3, yellow and blue paint are mixed in the ratio 2:1 to make green paint. A mirror needs to cover 33.6 meters squared with green paint. Each 500 milliliter tin covers 5.6 meters squared. Work out how many liters of yellow paint a mirror needs to buy. So first of all, I'm going to work out how many tins we need. So to cover 33.6 meters squared, I can divide that by 5.6 meters squared, which gives me 6. So that is 6 tins of the green paint. So now I'm going to figure out, well, how much actual paint is that? Each tin is 500 milliliters, so that'd be 500 multiplied by 6, which will give you 3,000 milliliters. And then I can share out my ratio, so when you add it, we get 3 parts. So I can divide 3,000 by 3, which means it's 1,000 milliliters of paint per every part of the ratio. But for yellow, that means I need 2 lots of that, isn't it? 2 times 1,000, which is obviously then 2,000 milliliters. And the last thing I need to do is convert it into liters. Hopefully you know that 1 liter is the same as 1,000 milliliters. They won't tell you that. So it's obviously just 2 liters. Question 4, the diagram shows a cylindrical tank. The tank has a diameter of 0.8 meters and a height of 1.5 meters. Water flows into the tank at a constant rate of 5 liters per second. Work out how long it would take to fill the tank and give your answer to 3 significant figures. So some things to pick up on here. We've been given the diameter. When we're working out the volume of a cylinder, we normally use radius, so we're going to have to deal with that. The other thing to consider is they've given us 5 liters per second. I know that the conversion between 1 liter is 1,000 centimeters cubed. So personally, what I would rather do is convert initially my measurements into centimeters before I start working out volume as well. So this one is 80 centimeters, and the height is obviously 150 centimeters. For the volume of the cylinder, we need to do pi times the radius squared, which, as I said, that's the diameter. So the radius is half of 80, which is 40 squared, multiplied by the height, 150. Now I'm going to leave that in terms of pi because we're not near the end of the question yet, but that is 240,000 pi. 240,000 pi, and that's obviously in centimeters cubed then. That's why I wanted to convert everything first. Then I would work out, okay, well that's in centimeters cubed, as we said, how many liters is that? So I would have to just divide by 1,000, obviously just knock off the last 3 zeros basically. So that would be 240 pi liters. Then I can look at the 5 liters per second. So how long will it take to fill the tank? So we've got 240 pi, don't forget the pi still, liters, divided by 5, which does give us 48 pi. However, this is now my final answer, isn't it? This is how long it would take in seconds. So let's convert it to a number now. They've said 3 significant figures, so that would be 151 seconds. And as you can see for this one, it's 3 marks. Question 5. 8 textbooks have a mean weight of 0.35 kilos. 5 dictionaries have a mean weight of 0.61 kilos, and 1 picture book has a weight of 58 grams. Show that the mean weight of all 14 books is 422 grams. So this is reversing the mean. In order to find the mean of 14 books, I need to add up all of the weights of the 14 books, divide by 14. So I need to work out the total weights. So for the 8 books, they each have a mean of 0.35 kilos. So I'm just going to multiply that, 8 times 0.35 kilos, which gives me 2.8 kilos for the textbooks. I'm going to do the same for the dictionaries. I need to do 5 times 0.61 kilos to work out the total weight of all the dictionaries, which gives me 3.05 kilos. And lastly, obviously it's only 1 picture book, so I don't need to work that out. That is just 58 grams. Now you can obviously see there's a difference. We've got some in kilos, some in grams, and our final answer is in grams. So you can convert it either way. Again, another conversion we need to know is 1 kilo is 1,000 grams. So I might convert these 2 here into grams. Obviously times it by 1,000, that's 2,800 grams, and then 3,050 grams plus our 58. Don't forget that last bit. So let's add those. That gives me a total weight of 5,908 grams. So now I can actually work out the mean. That's the total of all 14 books. So all I need to do is take that and divide everything by 14. Take my answer, divide by 14. As you can see, 422 grams. Question 6. Carlos used his calculator to work out the value of a number y. The answer on his calculator began 2.3. Complete the error interval for y. So, because this is a calculator one, we are using the logic of truncating. It's been truncated, hasn't it? Carlos has looked at his calculator. He has 100% seen the number 2. He's definitely seen the number 3. So 2.3 was exactly what was written. However, the only thing we don't know is what came after that. Anything could have followed after the 3. It's not been rounded up or down, it's just he read up to 2.3 and then stopped reading. So in this case, when you've got a truncated scenario, the smallest value is just 2.3. Maybe it was only 2.3. Maybe nothing came after it. It can't be any less than 2.3 because Carlos 100% saw a 2 and a 3. So 2.3 is the smallest, you just copy the same number. And then the biggest is technically 2.4. Now I know it can't be 2.4 because he definitely saw a 3. However, it could have been 2.3999999 to infinity, couldn't it? It could have been, we don't know because they just read the first 2 digits and cut off the rest. Right? So that's why the inequality symbols are important. It could be equal to 2.3 or greater, but it can't be equal to 2.4, just anything slightly less. So that includes the 2.3999999 to infinity scenario. And for this one you get 2 marks, a mark for each number obviously, and the fact that they are in the correct position. Question 7. Point A has the coordinates 2, -5, point B has the coordinates -8, 7, and point C has the coordinates -9, -4. Calculate the length between the midpoint of AB and the point C. So these ones you can obviously just go straight into it, or if you feel like it's helpful, you can just draw a little sketch on your paper just to give you an idea of where everything is and what's going on. So I've just drawn a quick sketch so you can roughly see what's going on. We need to find the length of this orange line. We have the coordinates of C, we don't have the coordinates of the midpoint, so that's what I'm first going to work out, the midpoint of AB. So I'll just put MP for midpoint. To work out the midpoint, for each coordinate we just need to add the 2 numbers together and divide by 2. So for example, for x, I'm going to do 2 plus -8 and half it to find the average. And then for y, -5 plus 7, again over 2 to find that midpoint. So you can obviously type that into your calculator or just work it out yourself. You should get -3, 1. So this is the point here, -3, 1. Now, as you can see, our orange line is a diagonal, so we're going to be using Pythagoras' theorem to work out the length of it. So C, we know, is at -9, and then our midpoint is at -3. So do you see how the length of this horizontal side of my triangle is going to be 6, isn't it? Then let's look vertically. So C, we know, is at -4. And then our midpoint, we've just worked out, is at 1. So that height of that triangle is 5. So now all we need to do is Pythagoras. So to find the length, I want to square root 6 squared plus 5 squared, which I can round to 3 significant figures as 7.81. And as you can see, that one was also 3 marks. Question 8. So Daniela invests £8,000 into a savings account. The savings account pays compound interest at a rate of X% per annum. After 5 years, Daniela receives £8,919.58. Work out the value of X. So I'm just going to set up my compound interest formula, which is on your formula sheet. You start with the initial amount, or the principal amount, which is the 8,000, multiplied by 1 plus the interest rate, which I don't know, so I'm going to put it as X, over 100, to the power of the time, which is 5 years. Now, in this case, I actually have what that is equal to. The answer would be the 8,919. And now the only thing in my equation that I don't know is X, so all I need to do is rearrange this. So the first thing I'm going to do is divide across by 8,000. As you can see, that gives me loads of decimals, so I'll just write down a couple, maybe 1.1149, 1.1149, ... Then I need to get rid of my power of 5, so I'm going to root both sides. So here, shift, and then I can choose whichever of your buttons has the option to change the type of root. So put 5 there, and I'm going to put answer so that I don't lose any of the decimals. So now I've got 1.0219999. Now you can see that I could actually just round that to 1.022 at this point. And from here I feel like you can see what you're going to do. We're obviously going to take away 1. That would be just 0.022 and times by 100. 2.2%. So there's your answer, 2.2. Question 9. Here are two cubes A and B. Cube A has a density of 1.75 grams per centimetre cubed and a mass of 112 grams. Cube B has a density of 2.4 grams per centimetre cubed and a mass of 518.4 grams. We need to work out the ratio of the side length of cube A to the side length of cube B. So for this one we do need to have our density formula, or just formula triangle, which is density is mass over volume. Now, given that we've been told density and mass, the only thing that we're left with is then volume. We might as well work out the volume of both. So for the volume of A, I need to do the mass of 112 divided by the density, 1.75, and that gives me 64 centimetres cubed. Then I'm going to do exactly the same for the volume of cube B. Mass is 518.4 grams over density of 2.4, which gives me 216. That's also centimetres cubed. So how can I relate that to the side lengths? Well, they are cubes, so think about it. How do I work out the volume of a cube? I take the side length, I multiply it by the other side length, and then by the third side length. But they are technically all the same side length. So I just need to cube root both of these. So it's effectively the cube root of 64 for A to the cube root of 216 for B. Now some of those numbers you might recognise anyway, but we can obviously just put them in the calculator. Cube root of 64 should give you 4, and then the cube root of 216 should give you 6. Now the last thing is then obviously they have said to put it in the simplest form, so that would become 2 to 3. So as you can see, that was 3 marks for density. Question 10. I've added in cumulative frequency to this one as well as paper 1 because it didn't come up in paper 1. So I would imagine it's still going to come up in either paper 2 or paper 3. You can go back to my predicted paper 1 and have a look at any of the questions where those topics haven't yet come up and practice those as well. So question 10. The times taken for 40 runners to finish a race were recorded. The cumulative frequency graph gives information about the numbers of minutes the runners took to finish, correct to the nearest minute. We've been told the shortest time was 37 minutes and the longest time was 84 minutes. And on the grid below, we need to draw a box plot for the information about the times taken to run the race. So we're just converting from a cumulative frequency graph to a box plot. Initially, what we can do is draw on these two numbers they've actually just given us. So for the first one, 37 minutes, just check the scale. You can see here, this is kind of a tricky scale because there's a gap of 10 squares, 10 small squares, but that represents 20 minutes. So each square is obviously going to represent 2 minutes. So to get to 37, we've got 30 is obviously in the middle, 32, 34, 36, can be halfway between this square here, isn't it? So about there. Then for 84 minutes is just 2 squares along from 80, so there. Now, what we need to know about box plot is we need the median, the upper and the lower quartiles. That's what we're going to use our cumulative frequency graph for. So let's come back here. We need the median. We've got 40 as our total, so obviously half of 40 to get the middle person, the middle runner, is the 20th runner. So I'm going to go across at 20 and then read off the x-axis. So to me, again, be careful of the scale. It'll obviously be the same as your box plot, but we can see here that that should be about 62 for the median. Then for the lower quartile, we do roughly the same, but it's obviously 25%, so we find 1/4 of 40, which is 10. So the 10th runner, we go across and down again. So that one looks to be about 54. And finally, we want the upper quartile, which is 3/4. So you can just multiply your 1/4 by 3, which is 30. So the 30th runner, which looks to be about 72. So now we've got our 3 values. We just need to draw them on the box plot. So 54 for the lower quartile, 62 for the median, and then 72 for the upper quartile. Now obviously I'm going to create a box with the middle 3, like so, and then I'm going to join the other 2 on the outside through the middle. So something a little bit like that, and that will give you 3 marks. Question 11. The probability that Marcus is late to work on any given day is 0.36. If Marcus is late on Monday, the probability that he is late on Tuesday is 0.87. If Marcus is not late on Monday, the probability that he is late on Tuesday is 0.25. Work out the probability that Marcus is late on at least one of the 2 days. So I would probably use a probability tree to lay it out. So our first branches is for Monday, and he's either late or not late. Late is 0.36, so not late has to add up to 1, which is 0.64. Then we want some more branches for Tuesday. Again, late, if he was late the day before, actually that means he's got more of a chance of being late the second day, which is 0.87, and therefore not late has to add up to 1, which is 0.13. Down here, if he wasn't late on Monday, then being late on Tuesday is actually 0.25, and therefore not late is 0.75. If we highlight the options that satisfy the question, he has to be late on at least one of the 2 days. He could be late and not late, he could be not late and late, but there is actually a third option. He could technically be late and late, because that's at least one of the 2 days, if not including both. So what you can do is work out each of these individually if you like. So that'd be 3 things to calculate. If you want to, if you feel like this makes more sense, what you can do is identify the only scenario that's not highlighted is if Marcus is not late on either Monday or Tuesday. So you could work that out and then subtract it from 1. So you've got 2 options here. I'm going to go through the whole 3 options just to show you how to use the tree when you've got more than one option, but you can do as I mentioned if you prefer. So when we're using a probability tree, we always multiply between the branches. So for the yellow option, that would be 0.36 multiplied by 0.13. Then for the green option, that would be 0.36 again, multiplied by 0.87. And the blue option, 0.64, multiplied by 0.25. So let's work them all out. So the first one is 0.0468, the second one is 0.3132, and the third one is 0.16. When you have multiple different possibilities from a probability tree, different scenarios that could happen, they can't all happen, right? Only one of these could happen. In reality, you can only do Monday and Tuesday once that week. So it's an or scenario. It's this or this or this. When we have or, it means we need to add. So when I add them, I get 0.52. So that would be my answer, 0.52. Now, as I mentioned, the other option is you can do 1 minus the only scenario that's not included, which is not late, 0.64, and not late again, 0.75. Do you see how that gives you exactly the same answer? So it's up to you which of those 2 methods you prefer to use. Show that x minus 1 brackets 2x plus 3 brackets x plus 7 can be written in the form ax cubed plus bx squared plus cx plus d, where a, b, c and d are integers. So basically, in other words, expand the triple brackets. So we always expand 2 first. I normally go with the first 2. You can technically do it in whichever order you like, but I'll just stick with the first 2. So x minus 1 times 2x plus 3. When I expand that, I get 2x squared plus 3x minus 2x minus 3. Now, before you go on, do make sure you simplify that. So I get 2x squared plus x minus 3. Now, I'm going to bring back my third bracket, or whichever one you're missing, bring that one back, which is x plus 7. Now, I'll show you how I like to expand this. I like to go from the 3-term bracket to the 2-term bracket, like this. So that would be 2x cubed, then 2x squared again, multiplied by 7, is 14x squared. Now I'm going to move on to the x in the middle. So x times x is obviously x squared. X times the 7 is obviously then 7x. And finally, move on to the minus 3. Minus 3 times x is obviously minus 3x. And finally, minus 3 times 7 is minus 21. So you should end up with 6 terms. Obviously, then we need to simplify it, collect the like terms to get back to just 4, as you can see in the question. The reason why I like to do it in this order is, if you can see, I've now got my like terms next to each other, so it's just a little bit easier, that's all. So I would have 2x cubed still, plus 15x squared, plus 4x minus 21. And there's my answer. That one is for 3 marks. Question 13. A cruise ship departs from a dock. It travels 674 kilometers correct to the nearest kilometer. It takes 18 hours to the nearest minute. Work out the upper bound of the average speed of the cruise ship. So, obviously we need the context of speed, distance, time. Hopefully you know what the formula is, but either way, formula triangle, it's distance divided by time. Now, we want the upper bound of the speed, so the biggest possible speed. So I would need to divide the biggest possible numerator, which in this case is the distance, isn't it, by the smallest possible denominator, which is the time. So do you see how I need a combination of the upper bound of the distance and the lower bound of the time? So the upper bound of the distance is fairly straightforward. To the nearest kilometre is just going to be another half a kilometre added on, isn't it? 674.5. Now the time is where it gets a little bit complicated because we've got 18 hours, but it is correct to the nearest minute. So I want to know, first of all, how many minutes is that? So 18 times 60 gives me 1080 minutes. Now I want the lower bound of this. So to the nearest minute, so I need to take away half a minute. So that would be 1079.5 minutes. However, I can't put that into my formula because I do want the average speed to be in kilometers per hour. So to go back to being hours, I need to divide by 60, which obviously does give us this really horrible decimal. So I am going to leave that in my calculator. And on my working, I might just write down the minutes, just so at least they can see that I've worked out the lower bound. But obviously in my calculation, I'm going to use in hours 17.9916 ... So just straight in with 674.5, and then underneath that, I'm going to write answer so that I'm not rounding any decimals. There we are, I've got my speed. So we've got 37.489. They haven't told us how to round it, so I would probably just have a look at it and see what maybe feels right. Normally I would give it at least a decimal place. I feel like that would round quite nicely to 37.5, wouldn't it? So I would go with that, 37.5 kilometers per hour. 37.5, so for 3 marks. Question 14. 27 to the power of a times 81 to the power of b can be written in the form 3 to the power of c. Show that c is equal to 3a plus 4b. So having a look here, do you see how I've got 27, 81 and 3? These are all multiples of 3. Can I change them all to 3 to the power of something? Well, 27 is 3 cubed, isn't it? So imagine that, 3 cubed instead of 27, still to the power of a. And then 81 is 3 to the power of 4, still to the power of b, and then just leave the other one. I'm just writing it as an equation now because when it says can be written in the form, that just means is equal to, is the same thing as. Now, obviously, using my index law, I can multiply the powers, so that's 3a times 3 to the power of 4b. Hopefully you can kind of see where we're going now. And then another index law is when we have multiply, we actually add them. So that would be 3 to the power of 3a plus 4b is the same thing as 3 to the power of c. Now, given that they both got the same base number, then surely you can write that the powers are also equal. So that's all you need to do for that one. Just notice that they're all related to 3 somehow. We've got 32 to the power of a quarter times 2 to the power of x is equal to 8 to the power of 0.4, work out the value of x. Now, you might be thinking, oh, I'll just type that into my calculator, but I wouldn't do that because you're going to get loads of decimals and it's not going to be helpful. What I would do is kind of think about what we did in part A. 8 and 32 are, again, multiples of 2. So can I rewrite those with a base of 2? So 32 is the same as 2 to the power of 5. So I can rewrite that. The reason why I do this is because I can only use my index laws when they have the same base numbers, so I might as well convert them all. And then 8 is 2 cubed, isn't it? Whilst I'm here, I might also change this decimal maybe into a fraction, which is 2/5. You can look that up in your calculator if you're not sure. Now, same as before, I'm going to expand the bracket, so multiply the powers. That would be 2 to the power of 5 over 4. Obviously, 2 to the power of x doesn't need to change. And then 2 to the power of 6 over 5. Then on this side, we can add the powers, so that would be 5 over 4 plus x is the same as 2 to the power of 6 over 5. And then, same logic as before, if we've got 2 to the power of something is equal to 2 to the power of something else, then surely those powers are equal to each other. So I can separate that as its own equation. Now it's just a linear equation. I just need to take away 5 over 4. So we might as well just do that in the calculator, mightn't we? We've got 6/5 minus 5 over 4. So that gives me negative 1/20, or you could write it as negative 0.05, doesn't really matter. So x is negative 0.05. Question 15. The diagram shows a circle inside an equilateral triangle. The circle touches the sides of the triangle, as you can see. The radius of the circle is 3 centimeters. Calculate the area of the shaded region. So what I'm going to want to do is obviously work out the whole triangle area, work out the circle area, and subtract them. Because these areas are kind of random shapes, aren't they? So that's the best way I can do it. Now, looking at the triangle, I don't have any measurements for it. All I know is the radius of the circle. So this is where I tend to start drawing things. This would technically be 3, wouldn't it? 3 centimeters. Then also, if you think about it, if you were to draw that, that would also be 3, wouldn't it? And so on. Anywhere where you draw a radius is 3. But I'm just drawing them so that they are touching exactly the triangle. Now if I add a line in here, do you see how I've got some triangles now? And think about it, if the circle is touching the triangle like this, effectively, for example, BC is effectively a tangent, isn't it? So we know therefore that this would be 90. Do you see how now I've got a right angle triangle? I know one of the sides is 3 centimeters, and I could use it to work out the base, but I do need something else. What else do we know about an equilateral triangle? Well, all the angles are 60 degrees, aren't they? Which means this one is also, as a whole, 60 degrees. But I would actually find this one more helpful, wouldn't I, in my triangle? What would be that one? Well, based on the fact that I've just shown you this is 3 centimeters, this is 3 centimeters, and they're both kind of cutting through halfway at the base through this kind of tangent line, this is exactly half, isn't it? So that would be 30. So now let's just tidy it up a bit. I can now just use basic trig to work out half of the base of the triangle. So this is the opposite. I want to know the adjacent, so that's just tan, isn't it? So we've got tan, and because we're looking to work out the adjacent, if I cross that out, you can see that we need to do 3 over tan 30. Which, as you can see, does give me 5.196 loads of decimals, so I will keep it in its third form for now, 3 root 3, as that is more exact. Now don't forget though that that is only half of the base of the triangle, so for the whole base, so for example for BC, for one of the sides it's obviously then double that, isn't it? So that's 6 root 3 centimeters. So now that I know each of the sides is 6 root 3 centimeters, I could just use my trigonometric formula for the area of a triangle, rather than worrying about the perpendicular height. So I'm going to do half AB, which would just be the 6 root 6, for both. And then sine C. So sine of the angle, the whole angle this time, which is 60 for any of them. As you can see again, I'm going to use the third format, so that's 27 root 3 centimeters squared. Now I could just work out the area of the circle, which is just pi r squared, so pi times 3 squared. So I'm just going to write that as 9 pi centimeters squared. And then finally, all I need to do is just find the area of the shaded region by subtracting my circle from the whole triangle. And now I can actually look at it as a decimal. So far we've got 18.491 centimeters squared, but as a whole number, for my final answer, that would round down to just 18 centimeters squared. Question 16. Given that x squared to 4x plus 3 is the same as 1 to 5, find the exact values of x. Now, for this one, you just need to know how to create one equation when you're given two separate ratios. So the way that I remember it is you basically just multiply the opposite ones. So the 5 times the x squared and the 4x plus 3 times the 1. You might remember it differently. So for example, this is how I would set up my equation. 5x squared is just 4x plus 3. The other way to set it up is when you divide them. So for example, x squared over the 4x plus 3 would be the same as 1 over 5. And then you can see if you were to cross multiply, you get the same thing. So whichever way you want to start this, just memorize one of those methods for creating an equation. And then from here, you can forget about the ratio. It's just solving equations. So because it's a quadratic, I'm going to keep x squared positive, which means I'm going to move the 4x and the 3 to the left. So that'd be 5x squared minus 4x minus 3 is equal to 0. Now I want to solve it. Now, normally I would try and factorize. However, because in my question it does say find the exact values of x, it's kind of hinting to me that there's a possibility they could have decimals. Because when it says exact values, they're normally referring to some kind of square root, some kind of surd. And when we have a surd, we're A, not going to be able to factorize, are we? But B, that normally means quadratic formula. So you can try and factorize, but I don't think you'll be able to. So I'm just going to straight away use the quadratic formula, which is obviously on your formula sheet anyway. So there's the quadratic formula. Obviously the letters line up in order A, B and C with your quadratic. Just be careful when you've got minus b here, if your b is already negative, that is a double negative, isn't it? So that would cancel out. So that would effectively be 4 positive, because minus 4 is obviously 4, plus or minus the square root of technically minus 4 squared. I would probably in my calculator just put 4 squared because I know it should be positive anyway. Minus 4 times a, which is 5, times c, which is minus 3. Again, if you wanted to, you could just make that a plus, couldn't you? Because you know that those negatives will cancel out. Over 2 times 5. So I'm going to type that into my calculator. And as you can see, it's given me this. Now, if you look at the actual number, it's loads of decimals. So they haven't told me how to round it because they've asked for the exact values. The exact value is this format here. Okay, the third format. So I'm going to have 2 plus root 19 over 5. And then technically 2 minus root 19 over 5, aren't I? Those are my two answers. So I don't want it in decimal format this time. So for x, I've got obviously two solutions because it is a quadratic. 2 plus or minus root 19 over 5. That's my exact version of both solutions, plus or minus, with the third. So that's 4 marks. So for question 17, we have circle theorems. A, B, C and D are points on the circumference of a circle centre O. EDF is a tangent to the circle. Angle ADB is x, as you can see, and also we've got angle BCD, which is y. We've also been told that the size of angle ADE, so the one on the outside, to the tangent, to the size of the obtuse angle BOD is 1 to 3. So BOD, we're actually going to have to draw another line between B and O. And because it's the obtuse angle, that means it's somewhere between 90 and 180 degrees. So that's obviously then this side of the angle, BOD. We need to show that x is equal to a third y. So when you've got a question like this, where it is circle theorems, but they've also thrown in letters, they haven't actually given you any angles, and we want to create some form of equation at the end, what we need to do is just find an angle that you can write roughly in terms of x, but then the same angle, you can also write it in terms of y, because if it's the same angle, you can put the two things equal to each other and then rearrange it. If you're not really sure which angle that would be in this case, just start by labelling things. For example, we might as well use the ratio as well. This angle here, if I know that this is y, I've got here, angles in the centre is double the angles at the circumference, haven't I? So I could label this one here, therefore, as 2y. Now, if I look at my ratio, if that one's 2y, that side, and what is this side based in terms of y? Well, I would normally divide by 3, wouldn't I? And then technically times by 1. That doesn't make any difference though. So that would give me 2/3 y for this side. So this one here is 2/3 y. So just start filling things in. Okay, what else can we find? What else can we do? Normally also with circle theorems, there are multiple different ways to do it. But I'll show you a slightly more direct route. Using alternate segment theorem. I know this one's quite complicated because there's a lot of lines going on. It's quite confusing. It's not as obvious. But if we just focus on this triangle here, BCD, and the tangent, do you see how y is technically the same angle as all of that together? So I can create an equation there and say, right, y is equal to 2/3 y plus x. And then all I need to do is just rearrange it to get what they've given me. So obviously I want x as a subject, so I'm going to subtract 2/3 y, which leaves me with 1/3 y is equal to x. And then we've shown it. As I said, you might have used different methods to get to this point. As long as you get to the point where you can show that 1/3 y is equal to x, that's fine. If you didn't do it exactly the same way as I did it, that should still be okay. And just so you can see, this one was only actually 3 marks, so not that many marks for a circle theorems question. And we weren't asked for any reasons, but if you were, obviously you would write down your main reason was the alternate segment theorem. Question 18, the curve C has equation y equals x squared plus x minus 6. The line L has equation 2y minus 6x equals 4. Using algebra, find the coordinates of the points of intersection of C and L. So whenever it says anything about intersections or find where they intersect, it's basically saying simultaneous equations, just in the context of graphs. Now this is obviously a quadratic one. We've got a linear and a quadratic, so the way that we normally solve those simultaneous equations is we substitute the linear into the quadratic. Now, I'm actually going to rearrange the linear though. I'm going to make y the subject just to make it easier. So 2y is equal to 6x plus 4, and then I'm just going to divide everything by 2. So that's y is equal to 3x plus 2. Now I'm going to substitute it in to the quadratic. If they're both equal to y, I can basically just put them equal to each other, can't I? So that's x squared plus x minus 6 is equal to 3x plus 2. Now again, I've got a quadratic, so I'm going to rearrange it to keep the x squared positive and get 0 on the other side. So I'm going to subtract 3x, so I get minus 2x, and subtract 2, so minus 8. Now, in this case, I feel like I'm going to give factorising a go. So x in both brackets, I'm multiplying to make a negative, so I need 1 plus, 1 minus. And then 2 factors of 8 that would add up to minus 2, that would be minus 4 and positive 2. Solve it, I get x is minus 2 or positive 4. And then the last thing is just to substitute those back in. I would like to substitute them back into not only the linear equation, because it's obviously easier, but also the rearranged version, because y is then just automatically the subject. So y would be 3 times minus 2 plus 2. So you can see that should give you minus 4. Or y should be 3 times 4 plus 2, which is 14. So now to just write them as the coordinates, we had minus 2 and minus 4 together, and then we had 4 and 14 together, and those are your points of intersection for 5 marks. Question 19. The number of deer in a forest at the end of year n is Pn. The number of deer in a forest at the end of the following year is given by Pn plus 1, which is equal to 0.9 times Pn plus 25. At the end of 2024, there were 500 deer in the forest. Work out the number of deer there will be in the forest at the end of 2027. So this is basically iteration, but with a context. So I'm going to set up my formulas. Our starting value, this is basically, if you imagine it, P0, isn't it? Or we can do P1 would be 0.9 times by 500, add 25. Now this is how I'm going to set it up in my calculator. So put whatever your starting value is just into the calculator, press equals, get rid of that. That's just now in my answer button, isn't it? Now I'm going to type in my equation, my formula. So 0.9 multiplied by, in this case where it says Pn, that's where I'm going to put my answer, and then obviously add 25. So if I press equals once, that gives me the P1 value, which in this case is 2025, isn't it? So that's 475 for 2025. P2 would be 2026. I'm not going to rewrite the whole equation again. Just press equals in my calculator. So 2026 is 452.5. And then we want 2027, so that's 3 times. So the last one, press equals again. That gives me 432.25. So you can write that down as your answer. I guess technically because they're deer, they're whole beings, you could round it to 432. I don't think that the mark scheme would be that fussy about the rounding. You could round it to 433. I think it wouldn't really matter. But as long as you've shown that working out, then you get all the marks. Now we do actually have a written answer for part B. So considering your results from part A, suggest what will happen to the number of deer in the forest after 50 years. So have a look what's happened. What's the trend? They are decreasing. So what will happen to the number of deer in the forest after 50 years? Something like it will decrease, or it will go down, or it will reduce. You get the point. Something along the lines of that. It will be less, that kind of thing. Question 20, we've now got some graph transformations. So here is the graph of y equals f of x, you can see. On the grid, sketch the graph of y equals f of x plus 3 in the brackets. So you just have to have memorized what this means. This is a translation on the x-axis, but the x-axis is always the wrong direction, isn't it? So that's actually minus 3. We're going to go 3 to the left. So because it's a sketch, just pick some exact coordinates. So for example, this one here would move to here, this one to 0, maybe go with this one would go to minus 3, this one would go to minus 1, and then the turning point. And then you can kind of just map out your sketch. You get the gist. Something a bit like that. Hopefully yours will look a little bit nicer than mine will. Then we've got another graph transformation for part B. However, this is now obviously trigonometric graphs. So here is the graph of y equals sine x. As you can see, for a range of between 0 and 360 on the x-axis. On the grid, sketch the graph of y equals 0.5 minus sine x. Now, if you notice, this is actually 2 marks, whereas the other one was only 1. So here we've actually got 2 different transformations. One of them is this negative. So I can rewrite it just to kind of translate it. That's like writing minus f of x, isn't it? And then plus 0.5. Some people might look at this and think we're going down by 0.5, but we're not. The 0.5 is not negative, it's positive. So we're moving the whole graph up by a half, and this is then a reflection in the x-axis. Let's reflect it first and then I'll move it up. I think that would probably be easier. So reflection in the x-axis means it's affecting the y-coordinates. So obviously 0 would stay there. This one that was at 1 goes to -1. The 180 stays where it is. 270 goes up to 1, and then 360 is where it is. So that's what I'd call my kind of interim sketch, right? My halfway point. Then all of those coordinates I then need to move up by a half. Let's get a different colour. So the 0 is going to go to a half. The -1 is going to go to minus a half. 0 to a half again. The 1 goes to 1.5, and as you can see, 0 to a half. So the pink is where I'm going to join up my curve. So something a little bit like that, and you can just rub out. If you did do an interim sketch, just rub it out. So get rid of all of these other ones so that they don't mix up the marking. So something a bit like that. Question 21. The diagram shows a shape made from a triangle and a sector of a circle, centre O, and radius 7 centimetres. So let me just label that. That's 7 centimetres there. AC is 16 centimetres, so label that. Angle ACB is 19 degrees. There. And OBC is obviously a straight line. Calculate the arc length of the sector AOB. Give your answer to 3 significant figures. Okay, so in order to find the arc length, we need to know this angle, don't we? We've got the radius, we just need to know that angle. So think about that. Okay, I need to know the angle. How can this triangle help me figure out the angle? Well, I could work out the angle on the other side, and then that just adds up to 360, doesn't it? So, do you see how, and especially because we're going towards the end of the paper now, do you see how this is going to be either some kind of sine rule or cosine rule? We've got a scalene triangle, we've got a mixture of sides and a mixture of angles. We just need to figure out, does it fit into sine rule or cosine rule? And have a look, we've got 2 sides and 2 angles, as in including the one that we want. That would normally fit into sine rule, but just double check that sine rule, they have to specifically be opposite each other, don't they? So you can see that yes, the 16 is specifically opposite the angle I want, and also the 7 is specifically opposite the other angle that I have. So that's perfect for sine rule. So from your formula sheet, because we're looking for an angle though, we do need to put sine of the angles at the top. Now you can label this whatever you want, let's just call it x for now. So sine of the angle x would be over 16, and that would be equal to sine of 19 degrees over 7. Now obviously I would need to rearrange that to move the 16 across, so multiply across by 16, and then I would put that in my calculator. Also, because I'm trying to find an angle, I can just straight away put sine inverse, because I know that for any type of angle with trigonometry I always do sine inverse. So sine inverse of sine of the angle 19 over 7, and then multiply that by 16. And you can see that gives me 48.08 ... So that's about 48 degrees. Now I'm not going to round it, I'm just going to write down 48 just for the sake of it. But remember, that's not my final answer. I then need to figure out my sector. So I also need to do 360 minus 48. And again, I'm not going to just use 48, I will use my calculator answer. So all of these decimals I'm going to keep. So 360 minus the answer, which gives me 311.91-ish. 311.91-ish. That's now my angle here. So the last thing is then for the arc length. We do need to know this formula, but parts of it are on the formula sheet. Obviously we want to have the circumference, which you either have as 2 pi r or pi diameter. So I'm going to use 2 times pi times the radius, because that's what I've got, which is 7. And then multiply that by the angle over 360 to get just a small amount of the circumference. So again, I'm going to use my whole answer from my calculator though. So this answer's still here. Type in 2 times pi times 7 times my answer over 360. And that gives me to 3 significant figures 38.1 centimetres. So that would be my answer. And that was for 4 marks. Question 22. Find the coordinates of the turning point on the curve with equation y equals 2x squared minus 5x plus 3. You must show all your working. So when you've got a quadratic and you've got turning points, this is always completing the square. So we just need to complete the square first. So this one's a little bit harder because there is a 2 in the front of the x. So I'm going to pull out 2, which leaves me with x squared. I like to just take it out of the first 2 terms. I kind of ignore the last term there. So that's unfortunately going to give me 5 over 2. You can obviously write 2.5 if you like. I just prefer to leave it as a fraction. And then I'll just leave the 3 on the outside anyway. Now I'm going to go and complete the square. So here I'm going to have a bracket with x minus, now I have to half this one again. 5 over 2 divided by 2 is 5 over 4. That's all squared, and then you always subtract this squared. So I know it's negative, but you know, when you square it, it will become positive anyway, won't it? So we're subtracting that squared plus 3. So that would be x minus 5 over 4 squared minus, that's basically 25 over 16, isn't it? Plus 3. Now I'm going to expand out the square bracket, so multiply all of this by 2. So I've got 2 and then brackets x minus 5 over 4 squared. And then also I need to times this fraction by 2, so that would just be 50 over 16. Now I know you can obviously put it in the calculator and get a simplified version, but I'm just writing it like that for now. Then all I need to do is just put these together in my calculator. So as you can see, I've got minus 1/8. So y is 2 brackets x minus 5 over 4 all squared minus 1/8. Now though, how do we get our turning point coordinates? Well, the x is always the one in the bracket. However, you do have to remember to change the sign. So in this case, it's already negative, so it will become positive 5/4. You could write that as 1.25 if you like as well. It doesn't have to be a fraction. And then the y is always the one on the outside over here, not the 2, just the one out here. And that one you do keep the same. So that is, as it is, negative 1/8. And you may write that as minus 0.125 as well as a decimal, that's also fine. So there's the coordinates of our turning point. Now our final question obviously has to be vectors. So we've got quite a difficult vectors question here, just in case the worst possible question does come up. This is what it is. You can decide whether you feel like this method makes sense for you to learn or to try and replicate if you get a question similar. Or you can decide that, you know what, it's just so complicated, I'm just not going to worry about it. And that's up to you. Vectors is definitely one of those topics where you just have to decide what your strategy is going to be. So question 23, we've got ABC as a triangle. M is the midpoint of BC. And then we've been given the vectors A to B is A, and then A to C is B. Now, N is not the midpoint, right? I know it looks like it, but it's not. They've told us that A to X and then A to M is 4 to 5. So just be really careful of that. This is 4, yes, not as a vector, but as a scale. However, this bit's not 5. Because it's not X to M, is it? It's the whole line. So technically, this is 1 to 4. So just be really careful what ratios they might give you. Then it says work out the ratio of A to N, N to C. As you can see, as I said, it's not the midpoint, otherwise there would be no question, would there? So when you have a question like this, there is actually a strategy to do it. There is actually a method that you can follow. And I've seen this question be asked in different ways, but it's always the same method in Edexcel. So we need to find 2 vectors from a line that effectively crosses through the one you actually want. The one that we actually are interested in is the ANC line, isn't it? So in this case, it's not quite as obvious because none of the lines technically go straight through. But if you imagine that this line here, if it extended, it would cross through, wouldn't it? So that's the line BXN. We want 2 vectors from that line. You can choose any 2 vectors, B to N, B to X, X to N, the other way around. Just find 2. Now, if you've decided that you're not going to follow the method, the first thing I would say is don't leave it blank. Just write down any vectors you think is helpful, because normally the first couple of marks are for exactly that, writing down different vectors. Now, I'm probably going to choose B to N, I think. I normally choose the whole line. I think that's sometimes easier. So I would probably go minus A plus, now I want to go from A to N. It's some version of B, isn't it? However, I want to do that because I, in the end, want to find the ratio for that line. So I need to include that line somehow. So here is where I know it's some version of B, isn't it? So what I'm going to do is I'm going to use KB to represent the scale from A to N. So it's a smaller version of B, and then we can work out what K is in the end. Then let's say I might work out B to X. That one is also minus A. However, I would need to come up here, wouldn't I? A to X. So this is where you're starting to have to work out other vectors as well. So over here, if I write down, I would need to know the whole of A to M, wouldn't I? And in order to work out A to M, I need to know B to C. So you're kind of backtracking a little bit. You might as well write down B to C anyway, and either way it's quite easy, isn't it? B to C would be minus A plus B. Therefore, A to M would be A, and then because I'm going to the midpoint, I know that M is the midpoint, that would be half of B C, wouldn't it? So this one I'm just going to expand out whilst I'm here. So that would be A minus a half A, so that's a half A plus a half B. Now, I wanted originally A to X, didn't I? So I need to apply this ratio, as I've said, 4 to 1. So you need to be able to convert ratios into fractions. I just want the side with the 4. So that's like 4/5, isn't it? 4/5 of the line. So A to X is 4/5, a half A plus a half B. Again, I'm going to expand all of that out. So that's 2/5 if you wanted. 2/5 A plus 2/5 B. So back to what I was saying, I want B to X. So I want minus A plus AX, which is plus 2/5 A plus 2/5 B. And again, collect the like terms here. So that would be minus 3/5 A plus 2/5 B. And there we are. I've got my two vectors from the line that kind of intersects or crosses through the actual line I want, and I've included a letter to help me work out exactly that ratio. This is then the bit where I feel like it gets a little bit kind of abstract. You might go, I have no idea what you're about to show me. That's fine. You might just get to this point and go, I'll take half the marks. That's also fine. You don't always have to finish a question. We need to create simultaneous equations for each of the A coefficients and the B coefficients. The reason why I've chosen two vectors from the same line is because if you think about parallel vectors or vectors on the same line, one is a multiple of the other. Obviously, Bx is a smaller version of Bn, isn't it? It's not exactly equal, but it's a smaller version. So I want to compare the coefficients. So the coefficient of A is technically -1 there, isn't it? And then this one is minus 3/5. Now, obviously, I'm not just going to write -1 is equal to minus 3/5, because it's not. Mathematically, that's completely incorrect. And as I've just said, size-wise, they're not the same. So technically, we do need to bring in another scale, a scale for Bx versus Bn. Now, that's a scale that I don't particularly care about, but I do technically need to put it. So I like to put it, I guess in this case it doesn't really matter, but if you've got a question where one coefficient is obviously more complicated than the other, I'll put it on the easier side. So, for example, -1 is equal to minus 3/5, and let's just use x. So I'm going to write here, x is my scale for Bx, just so you don't forget what I've said. You can use any letter, doesn't matter. This is the equation for my A coefficients. Do the exact same for the B, and whichever side you put the x on, put it on the same side for B. So B, we've got k is equal to 2/5 x. You see how now I've got k as part of an equation? Because k is the thing I actually want, isn't it? There's my B coefficients. Now I do need two equations because obviously I technically have two letters, but I actually don't care about the x. I do want to get rid of the x in order to find what k is. So what I might do is rearrange this to get x as my subject. So that would be -1 divided by 3/5, which is basically positive, but also the reciprocal, isn't it? So what we're saying is x is 5/3, and therefore, if I substitute that in, do you see how k would be 2/5 times 5/3, which gives me 2/3. So what was the whole point, actually? We've almost forgotten what we were actually doing now. K was the AN section, wasn't it? It was saying that that's 2/3 of the whole line. So therefore, N to C section must be 1/3. However, they have asked for it in a ratio. So all I need to do is then know how to convert from a fraction, or from technically two fractions, back to a ratio. Well, converting back into a ratio, you just take the two numerators, don't you? See how that would be 2 to 1? So your answer here is 2 to 1. So find two vectors from a line crossing through the one you want, make simultaneous equations from the coefficients, and then solve it. That's kind of the general gist, but it is kind of in reality more complicated than that, isn't it? So obviously this is a 5-mark question. The answer is 2 to 1. So those were all the questions on my own predicted paper 2 higher tier Edexcel paper. As I mentioned at the beginning, please do not use this as your only revision. Please do not take the topics from this paper as the only topics that will come up. I obviously don't know what's actually going to come up, so please do not limit yourself to just revising these topics. Ultimately, it could be anything from the syllabus really, so make sure that you are doing wider revision and use this as just one of the resources before your exam. So thanks for watching this video. If you found it helpful, make sure to like and subscribe. We will be going through this paper live next week anyway, so you can also join us there. And also check out my predicted paper 1 for any of those topics that haven't yet come up that might then be moved into paper 2 or paper 3.